Hello again, we are talking about expanding polynomials today, and we are going to pick up right where we left off in the last video. So here we are trying to expand the polynomial 11x plus 21 in parentheses, multiplied by, in parentheses, 121x squared plus 462x plus 441. So, as I talked about in the previous video, we are going to apply FOIL in order to expand this polynomial. However, it's not going to work in the conventional fashion. What we're going to do is we're going to multiply 11x by all the elements within this part, and then multiply 21 by the same. So let's do that. This is going to be really long and tedious, but that is the only way we are going to get an answer. So first we have 11x times 121, which will yield us 131x cubed. Take note of that. Then with 11x times 462, and that is 5,082. And then lastly we have, well, let me make sure to put in that variable x squared. Finally we have 441 times 11x. That gives us 4,851x. Alright, now let's do the same thing with 121x, well, rather 21 multiplied by all the elements. Let me rush through this really quickly. 2,541 x squared. Plus 9,702x plus 9,261. Finally, that shall give us 1,331x cubed plus that 7,623 x squared plus 14,553 x plus 9,261. Well, that was a bit complicated, but that is the procedure that you will have to follow in order to expand this form of the polynomial. The rules of multiplying, of expanding the x plus y squared form shall help you a bit. However, the next part does not really have a rule, and you shall simply have to FOIL it out. Or in this case, I can't really say FOIL because you're not really using FOIL. That is the general method that you shall use. If all else fails, just remember, multiply every single element within one parentheses by every single element within the other. And with that, you should be golden. It's just really big numbers. Alright, I had another problem prepared for this particular form. However, due to the time taken by the previous one, I think I shall not tackle that. Alright, so let's move on to the next form, which is, well, fortunately they've provided us with ax squared plus bx plus c times dx plus e. So we don't need to FOIL for the first step, or rather apply our rules for the first step. However, it's still a lot of multiplication. So remember our concepts again: multiply every single element within one parenthesis by every single element within the other. 4x squared times 2x, 8x cubed, 7x times 2x, 14x squared. Things are just so much easier with smaller numbers. I love small numbers. So we have plus 26x, and now we multiply 1 by all of that, so I can just copy everything down. We end up with 8x cubed plus 18x squared plus 33x plus 13. Again, not as long as the previous one, but still relatively tedious compared to the simpler forms that we saw previously. Another problem prepared, this one would be important to note. This one, with this form, we would have to learn a new rule. So I shall do this form instead of skipping it. No. This equation should say 16x squared minus 12x plus 9 times it in parentheses 4x plus 3. So let's FOIL it out. I'm using that word inappropriately right now, but let's use that in substitute for multiply every single element. So 16x squared times 4x would give us 64 x cubed negative 12x times 14x minus 48x 9 times 4x would give us 36x. We'll multiply 3 with everything to get that, and finally 27. Alright, this form, there's a very special rule that applies to this form, and we shall see it right now. Negative 48x cancels out with positive 48x, plus 36 cancels out with minus 36. What we end up is a very pretty 64x cubed plus 27. Now, note this, and note this. This is the sum of two perfect cubes. It's 4x cubed plus 3 cubed. You'll need to remember this rule also, because it is extremely useful in expanding some of these really complicated polynomials. However, it applies only to a very specific form, and that form is a squared x squared minus a b x plus b squared in parentheses all of that a x plus b. I'm going to have to cut my video short again. Software limitations due to Microsoft Encoder software. So we shall discuss this rule for the next video. Thanks for watching.